It's known that 26% of adults in the UK use a certain app. A researcher selects a random sample of 5,000 adults in the UK, and the random variable x is defined as the number of adults in the sample who use the app. This is a binomial distribution because we have a fixed number of trials, and we have a probability of success of 0.26. We're going to assume that people are picked independently. But yeah, there's two outcomes, fixed probability, fixed number of trials, etc. We're then told that the probability that x is less than n is less than 0.025. We're asked to calculate the largest possible value of n. Now, there are graphical calculators that can do inverse binomial distributions and work this out straight away. I do not have such a calculator myself, and I'm going to assume you don't. But if you do, have a look into it, see if you can find that function. Else, I'm just going to be doing trial and error, although I am afterwards going to talk about how you could use a normal approximation to do this question. So I'm just going to be subbing in some different values for n and seeing if I can get around 0.025. I'm going to be looking for the crossover a little bit when you do a hypothesis test and you look for where it goes between the significance levels. Okay, let's go for it. So I've got my distribution. I'm going with binomial CD. Well, I mean, I could do several at one time. That's not a bad idea, actually. So I'll maybe now remember it's about a quarter, and I want quite a small probability, so maybe I'll just put 500 in. Let's put 1,000 in. Well, let's just see what that gets us. So n is 5,000, p is 0.26, and we get some very small probabilities. Okay, so we need to go bigger. So let's go with let's go 1,500. 2,000 seems like it's going to be a bit too big, but let's just go for it. It doesn't take too long. Okay, so they're way too big. So now we can hone in on it. So let's go with 1, 1, 0, 0, 1, 2, 0, 0, 1, 3, 0, 0, and 1, 4, 0, 0. We know it's in between these because we've gone from 0 to 1. Okay, so that 1,300 is still way too big, but 1,200 is too small. So let's go 1, 2, 1, 0, 1, 2, 2, 0. Right, now we're getting somewhere. Because look, this is 0.027. We've gone just over it. So it's going to be less than that. It's going to be more than 1,230. So let's go with, let me go with 1,239, 1,238, 1,237. And there we have it. This is where the crossover is occurring. So we've got less than or equal to 1,238 is 0.0232. And then less than or equal to 1,239 is 0.0251. Should be noted that this is the probability that x is less than 1,239, and this is the probability that x is less than 1,240, because we do have that here. And so I can see that 1,240 is too big, just about. But so 1,239 is the largest possible value of n that gives me a probability less than 0.025. N equals 1,239. Okay, let's have a look at an alternative way of doing it. I mean, it works fine. Didn't take too long, and I'd recommend it to be honest. But if you don't have inverse binomial on your calculator, okay, here's how you can do it. So we can do a binomial approximation. So let's y be a normal distribution, and then this is given in the formula book. The mean is n times p. So 5,000 times 0.26, which ends up being 1,300. And then the variance is n times p times 1 minus p. Okay, not going to prove that or anything, but we times the 1,300 by 0.74, we get 962. So standard deviation is the square root of that. So we want the probability. Now I'm going to do it. You'll get away with doing it this way. I will talk about something called a continuity correction at the end. But let's say the probability that y is below this value of n, let's call it n, is going to equal 0.025. Okay, and then whatever value of n we get, we just have to go slightly lower than that. And now we can do inverse normal. So what we're doing, let's just remind you, is that we've got some sort of binomial distribution. We're actually fitting a normal distribution to it. And you can do that when n is sufficiently large, when p is sufficiently close to 0.5, but it's actually more about the combination of both of them. It is okay here. I'm not going to go into lots of detail on that. So I can do inverse normal, distribution, inverse normal, area 0.025, sigma square root 962, mean 1,300. And we get 1239.2. Which means the smallest integer value, I probably shouldn't have called it n, to be honest. Let me change it to c. So smallest n is then going to be 1239. That's quite a nice way, requires knowledge of the normal approximation, but it's worth learning about and understanding. So I highly recommend it. And one final thing I'm going to say is like on the specification, this is absolutely fine. In reality, it's not, because when you convert from a discrete distribution to a continuous distribution, there's actually a bit of a problem, because for normal, it doesn't matter if you're using less than or equal to in a continuous distribution, because you're doing an integration. It doesn't distinguish it. But in a discrete, it does. If you do less than or equal to 8 and less than 8, you'll get different answers. And what you actually have to do is something called a continuity correction. So if I want to do, right, I've got my binomial distribution, and we kind of imagine instead of it just being this line that's going up, we turn it into these little rectangles. Okay, so now instead of the height being the probability, the area is the probability, because this is going to be 1. All the widths are going to be 1, because I'm going from like 7, 8, 9, for example. So if I want the probability, sorry, this is a very brief explanation, by the way, and I do have videos with more detail on it, or you can have a look, just look up continuity correction. It's going to apply for any discrete to continuous approximation. So if I want the probability that x is less than or equal to 8, then what I need to do is do y for my normal distribution. If I want to include 8, I'm actually going to need to go up to 8.5. So it's going to be less than or equal to 8.5. If I wanted the probability that x is less than 8, so now I actually don't want I don't want this bit here, it would go to 7.5. And that is our continuity correction. So although not needed, not on the specification, technically in this question, we should apply a continuity correction and it should be C minus 0.5 because I actually don't want to include the value C itself. So I'd get C minus 0.5 is 1239.2 and C would equal 1239.7. Our smallest value of n would still be 1239, so it doesn't affect it in this scenario. It could in another, actually. It could, it just happened. I mean, I think they selected the question so that it doesn't, personally. But yeah, I just want to make you aware of it. Well done if you've made it to the end of this video. So three different ideas here, really. You can just use binomial and kind of do a little like narrowing search to get the answer. Not too bad. Just a bit of patience and, just think about values to look at, like make your gaps big, and then make them smaller and smaller until you get the crossover, which we have here. Method 2, use a normal approximation. Since n is large, p is close to 0.5. We get this approximation. We can do inverse normal and get the same answer. Third idea is just to say, you know what, actually, although that is accepted, strictly speaking, we should apply a continuity correction, and then you have to slightly modify your less than your number here, either add 0.5 or minus 0.5, and go from there. In this case, we get the same answer. Okay, thanks for watching.